Oh hi, I didn't see you there. I'm James Levy from the 5870 Robotics team. When you've got a robot and you've got a design in mind, and you ever think, man, this is a good design, but how do I make the part to make this design work? I can't fabricate this out of aluminum or anything else. Well, now you can. FDM 3D printing. It's a method of fabrication that's very versatile and widely available to anyone who can spare a few $100. But why is it so versatile? Well, the answer is twofold. To start, as you can see, there's a very large area of where you can make pretty much anything. And because of the way these axes move, you can just make stuff without any changes to this to the hardware. Just change your model, import it, and you're good to go. The second reason is, honestly, material. When you think of 3D printing, you think plastic. And largely, that's correct. But there's so many types of plastic and so many different types of plastic that you can use for 3D printing. This here is polylactic acid, or PLA. Probably the most common type of filament to print on a 3D printer because it's cost effective, it's fairly durable, and it prints quite easily. It doesn't lift up from the bed. The downside of PLA is it's not the strongest. While it can withstand some stress, if you need something to not break, PLA probably isn't the way to go. You'd probably be better off with something like ABS, which you've probably heard of before. It's used to make Lego. That's quite strong, isn't it? But there's some other materials that you can use that are quite a bit stronger. Say, Kevlar? Yeah, you can print Kevlar on a 3D printer. You can even print titanium. That's right, there's some 3D printers that can print titanium. NASA uses it all the time for engine gimbals. But that's not the point. The point is, it's really versatile. I mean, like, you can make a lot of stuff. Pretty much anything. Another big advantage to 3D printing is that you can make things in one piece that you couldn't otherwise do. This geared bearing, for example, this was printed in one piece. And honestly, it couldn't have been made any other way because of the herringbone gear design. I'll show you with a little bit of movie magic. You see, let's say that this is the inside of our gear. This is the inside of the big gear right in here. Normally, the gear's teeth, the tip of the teeth would look like that. But that's not how they look here. These look more like this. A herringbone design. Because of that, the way they mesh, you can't add another gear in there after it's been made. Now let's get rid of this with some more movie magic. No, Mom, get out of here. All right, now we understand a little bit more about why we 3D print things, but we still don't know how we 3D print things. Well, I know, you guys don't know, but I do. That's why I'm here, I'll tell you. Don't worry. Honestly, 3D printing is really a simple concept. Almost all 3D printers consist of these elements. An X-axis. As you can see, this is the axis that moves the extruder back and forth. This is driven by a stepper motor over here that drives a belt. The belt is firmly attached to the extruder and another bearing on this side. So what happens is, as the motor turns, this thing moves back and forth based on where the motor goes. The reason that it's a stepper motor is because those are the most precise kind of motors. And this is a very precise thing. It's also got a y-axis. This moves the bed back and forth and operates, honestly, really the same way, with another stepper motor back here that moves back and forth. These two work together to create any kind of shape on a two-dimensional plane horizontally. Now, what else do we have? We have a z-axis. This moves it up and down. This uses a couple of stepper motors here and here to turn a big screw that's attached to a bolt-like thing here. As this is moved, the extruder assembly moves up and down. This just moves up just a little tiny bit at a time when you're actually printing, almost imperceptible based on the layer height. That's because when you print something, it's made in individual layers. If you look very closely at this, you can see all the individual layers. This was printed facing up like this, and it had to go and print each one of these, and that had to be done very precisely. So you can't have this thing moving up by a significant margin every time. Next thing that every 3D printer has is something that I can't show you right here because it's too small. The extruder. That's this piece here. This is where the magic happens. It's not actually magic. Now, I need some help with my friend Science Board again. Science Board, come here. That wasn't magic. That was editing. And so was that. So, let's say that this is your roll of filament. This is actually my roll of filament, but let's pretend that it's your roll of filament. So, this is going to get how is it held into the extruder? Well, actually, quite firmly. I can't pull this out. I'm sure if I pulled hard enough I could, but I can't pull that out. So the way that works is this. And this is a top-down view of that. This is two meshing gears that are driven by a stepper motor. This here is a stepper motor. It actually says stepper motor there. This here is a stepper motor, and that's driving these two. And this is the filament in the middle here. And those are counter-rotating gears, so that'll pull it down into the rest of the extruder. Now the next part of the extruder is this nozzle here. Or I guess not the nozzle yet, but the heated element. And this is, in the case of PLA, it gets heated up to about 215 degrees because PLA melts at about 140 degrees. That's Celsius, that is, for all you American pigs. Yeah, Celsius. And so, the reason it gets up so high is because the hotter it gets, the smoother it gets. The next part is the nozzle. You can't actually see the nozzle on the outside here. You can see it. It's a brass nozzle, and the filament gets pushed into the nozzle, and you'll notice that the filament being extruded is nowhere near the diameter of this, which is 1.75 millimeters. That's not all filaments, but I think that that's fairly universal, as most of them are that diameter. And it gets extruded, and the way that it gets so much smaller is because, again, it's so hot. So pushing it down and getting it to that diameter, if it's necked down, in this case it's 0.4 millimeters, it's necked down, it's much easier to do that if it's so hot and so smooth. Now this is our object that we're printing. It's not a very good object, but it's our object. And Science Board, I think we're done with you. Oh my goodness, he died. Now, we know two things. We know why we 3D print things, and we've got a basic understanding of how it works. This isn't a tutorial by any means. It's just to give you a bit of insight. Now we can start to think of, how would you use this for robotics? I'm sure you're probably thinking of some scenarios in your head, but let's just run through one real quick. I'll just show you, how do you get from needing to make a part to designing the part to actually putting the part onto here and making it a reality. So, let's go to the computer mobile. First of all, you gotta remember, before operating any kind of equipment, no matter how safe it is, you've gotta don your comically over-the-top safety gear. Safety is never a joke. Let's get printing.
Okay, so let's just say you need to mount a motor at a very specific angle. Let's say 33 degrees. This is what I've made here. It's just a bracket. It's got a couple of holes here. Nothing really too fancy. This is just a demonstration piece. This isn't really something that you would necessarily make, but this is it. So export it. Now this software here is the Prusa slicer software, and what this does is this takes a 3D model and it puts it into slices. And this is by no means a tutorial, because there's a lot better tutorials online that you can find. But this is just sort of a general, this is how it works. So this will give you the amount of time it takes to print, but more importantly, this will determine how detailed your model is. So if you're just making something that needs to function, probably you'll want something that's a good 0.2 millimeters is generally good, but for this demonstration, just for the sake of time, I'm going to do 0.3 millimeters. Save that. But again, this isn't a tutorial. This is just showing how it works. So you can do all kinds of things in here. Just sort of you can mess around with controls. You can change the placement of stuff. You can move it around. You can change the size of things. All these, it doesn't really change anything. Now, I'm going to make this smaller just for the sake of time, and you slice it. And this is where things get interesting, because what you see here, you'll notice if you zoom in, this doesn't look quite the same. These are the layers. This is what it does. It slices your model into layers, and this gets you exactly what you are looking for. So this is now printable. And you just have an SD card, which you plug in. Just put it on the card.
All right, well, that came out smaller than I expected. But honestly, that's okay, because it's just a demonstration model. But this is it here. It's a little bracket. It's pretty small, but you know, this is it. This is what, it's just about the process of taking it start to finish, making a thing. Whatever. It's not a get out of jail. Doesn't guarantee you win. In conclusion, thanks for watching, and wear your safety squints.